Hello again. We can continue now with the rest of our tutorial. So previously, I'm just gonna delete this one. That was not made. So previously, we recorded the. I'm gonna unplug my actually. No, it's not plugged. We were animating our ship based on our clip. However, I did recognize that once the scene gets reloaded, we start getting nans. So that's causing our ship to disappear. So I'm going to just not export the RZ because I think here we did a little wrong math somewhere. So it's actually breaking. So we need to get back to this to actually do the adding of the banking. But like this now it's fine. It is at the moment. So what we can do next is to, where is it? Object level. Now I want to add my second ship. So I'm just gonna copy, paste this. So this should be still now exporting to ship A1. This is one of the cool things that Houdini does, I think, quite well. It's like it just figures out, hey, this is being copied to as a duplicate to another thing, and then just kind of updates the old proper paths. So this is going to be ship B. So in this case, we want a ship that is further in front, still using the same noise, because right now they should be overlapping. If I turn this off, I see the other ship. So if I just kind of look like that as well, so our camera is at the back here, our first ship, our second ship will be in front, which means we can take our, go to our chop net, and where's our lag filter? We can add a lag to this guy to offset our, so like offset our keys where we use like a delay. So I'm gonna just copy this. Ship B, not the geometry, the chop net. So I'm inside chop net. I can put it anywhere I want pretty much. Doesn't really matter, but I'm gonna put it at the top. And from here now we can change our delay value to offset our ship. So we do, so now it's, because it's the same value as the camera, therefore it went a bit front. Okay, so I guess something like this maybe. Let's play a little bit there. So it's gonna do the exact same thing, although from the camera it will probably look very similar. So now what we want to do is to probably because we had this noise, just really change its seed, I suppose, and maybe even the probably the amplitude. So if you press, oh, that's too much. Let's check our motion view. Yeah, that's way too noisy. It's because our roughness is too much. Actually, where is this coming from? Oh, that's the exponent. Yeah, so if I press play now. Okay, but we are really too close to each other. I think that's the part that we need to adjust as well. Let's look from the camera again. Let's go forward. Yeah, we need to. Let me put this actually to 0. I suppose we can actually delay our camera, let's say to 4. So when does our camera start moving in this case? It starts moving at 150. So then we can probably go to our ship A, paste this guy in here, and then maybe go 2, and then finally the last guy 0, which means that it's going to be in the most up front. I believe Yes. So now, yes, it's working much better. So basically, I took I offsetted the camera by for, I believe these numbers work in seconds. So there's 4 frames, 4 seconds. So it's 100 frames, almost 100 frames. So then the other one is 2 seconds, and then the other one is the actual camera. But then this kind of creates a little offset to our camera, I guess. So which means that we can start our simulation on 150. So let's put that as our input timeline, and let's press play to see what it's doing. Oh, it is really slow now. Oh, it's because we're displaying the high-res buildings. Here we seem to have a little flickering. Let's fix that flickering. We're looking through the camera. That's because of our minimum clipping value is way too small. Just kind of fixed that problem. Can we have some better quality viewport? This lighting is not working very well. We have too many lights we don't want in the viewport, so I'm just gonna turn this off and maybe just create a skylight that is not going to be rendered, but just for visualization it might be more useful, or even actually yeah, that should be fine. But we can't. Can we get shadows from the sun? No, this is not gonna work. Let's try. It comes really slow, but okay, yeah. It's not really doing much. Doesn't matter. We're just trying to get the feeling right. We're gonna render it anyway. Houdini's viewport is not the best out there. The last thing we were gonna check was, okay, so I was gonna replace the high-rise buildings with the proxy to see to see how the motion, if the motion is working fine. So that was our low poly, high poly. Let's switch to our low poly so we can have a bit more faster preview. So if I press play, still kind of feels too slow, to be honest, but we can speed up our keys. That's probably something yes, this feels like a slow motion. I say we should speed this up. So let's maybe start from the camera. I don't know, but I believe there must be like something like a refit or retime. Record sample, arrange. I am not sure, but I'm pretty certain there might be a node for this. Constant waveform channel, copy, extract. Limit, extend, warp, I guess. Pre-warp channels, warp curve. No, this is not it. This needs to. Okay, let me Google that very quickly. Well, actually, didn't have to use warp. I found the stretch here. Basically, I guess that's what it's doing based on the documentation as well. It's just stretching the keys. Stretching the value. So if I press play with a value of 0.5, it's pretty much twice as fast, and it kind of feels better. So I guess we're gonna go with that, and which obviously needs to be applied to everything else. So let's just do it here as well, and finally here as well. Hopefully that's gonna put the ships where they should be, and it does, but we're just a bit too far now. I guess we can then go back to our camera to kinda bring back the distance a little bit reasonable. And it's still gonna start from, I think now we pulled back the time, so we can start from 100. Okay, so if you press play, now things are faster, feels a bit more natural. Our ships are still a bit big, which is weird. I think I have too many ships compared to my previous scene. Okay, so then because we're speeding up, and we finish our, let's say, shot at 600. Okay, that feels better. Now we can continue by creating our so we have the ship simulation, ship we can the weapons that we're gonna put on the ship A to shoot on ship B, the machine gun, let's call it. So I'm going to create another network box here. Let's just disable this, is jumping around. I don't know exactly why. Let's create another network box to keep things a bit more tidy still. This is actually, because we're going to create, as I have on my other scene here, the little muzzle effect that we have on these nozzles. It's like these are like thrusters, so our spaceship can maneuver in space as well, which is the little red simulations you see on the edge of my video. But that can come after. The interesting part, I think, is a bit more on the shooting part. So in order to set up our guns rig, we are going to start by gathering our ship B. Therefore, we're going to create a geometry node here. Let's call it ship B guns. Okay, no, I think no, because ship B is in front, so we need to call it ship A guns. Okay, so let's dive inside and bring in an object merge into this object, and we want this guy in here. We could have just copy pasted in there as well. Oh no, we can't, because this is the one that gets to transform. So in here we're gonna set it to, not this one, sorry, this is ship to pair ship out. So we come here. Now this one is gonna be actually the baked in world space. So let's put a blast node, and as you remember in my gun A, we had these two boxes that we attached. We need to make sure that they have normal, which they do, but I'm going to create a new one anyway, just in case it gets corrupted or something. Leave that to points. Okay, so now what I want is to create a point right in the center of each of these primitives, and then I want to copy these normals to the center point. So drop an attribute angle, and then type add point 0 on itself at the position. This needs to run in the primitives. So let's change the type to primitives. It's going to create the points, but I don't want the primitives. I just want the points. So I'm going to remove the primitive, remove prim, add prim num, and also remove 1. For those who are curious about what that means, is the 0 is operate on myself based on the prim number, and then 1 is also saying that remove the primitive as well. So if I do F1 on the, if I move the mouse on the function and hit F1, Houdini pulls up the help documentation to me, and then here it explains what it actually does. But now I don't have those normals anymore, so I'm gonna create an attribute copy from here to here on the normals, and now I have the normals that are always pointing in front of the gun. Okay. Now what I did next is I'm gonna create a little tube, and I'm going to say I guess we can do a we want a polygon on z-axis, and then basically let's say I want something like my first radius to be 8, and I'll show you what that means now. And then height 100, that's 100 meters. Okay, and I'm gonna put a copy swap now, copy the points and primitives points. Okay, and then now we have ourselves like binoculars, but the thing is this is copied from the center, but we know the height of our the length of our object, so I'm just gonna offset on z-axis with the half amount of the length, which is going to put it at the tip of where our points are. Okay, so now we have something like this that is looking in front. Imagine these are the eyes of our pilot. Okay, we want to close the end caps. Don't we want to end caps? We are not ending caps. We should be ending caps because we're going to use it as creating a group. Okay, so now what I want is now that I want to bring in my other ship with another object merge. Actually, I guess we can just copy paste this, and then because we call it just ship B, and then just change this to B, which should take care of that. Where's our ship B? Somewhere here. Okay, so it's really far based on our simulation, based on our frame offset. So I guess in this case we need something bigger, a lot bigger, like this. I suppose wider, so we can shoot something that will actually even longer. Okay, so every now and then they shoot even longer. Okay, so now every now and then our pilot will be able to align the ship, and the ship will fall inside the cone, and then he will shoot. He's really not good at it, but sometimes we want him to miss as well, so I guess we can increase the radius so it triggers the I think this can be 0. Yeah, so it triggers the let's go, it triggers some misfire. Okay, so that's, it's gonna capture more. It's gonna fire every time it's in the cone. All right, cool. So what I want now is, though, because my geometry may not necessarily have enough surface detail for this to be captured, but maybe it does. It's fine. I have enough points. So now then I would like to test this. I would like to create some target points based on point detection. And I'm going to call it this group insight, and turn on bounds by object. So depending on the performance, because this is quite slow, I guess. Come on, yeah, it's inside now. Is it selected? Inside points, yes, it find it, but I don't want this to be slow. All right, now it is. So in the case, I think instead we can do volume sampling. So let's convert this to VDB from polygons. Let's go something big. So it creates even bigger. So that's okay, even bigger. Okay, bigger the size, faster the conversion is. So then we can plug this guy in here, and then I guess change it to volume, which is supposed to be a lot faster. Insight. This ship has a lot of points. I think we don't need that. We need the surface points. Maybe that might actually make things faster. So let's put a time shift, because it has a lot of interior detail, and I think we just need some surface points so it doesn't have to create so much detail. So we just need to, I guess, freeze, and any frame is fine because we're going to interpolate points. So scatter some points then. I guess something like 500 is enough, or even 1,000. So for now, let's say 500. This is okay. And we need to turn on source prim UV and source prim, so we can use interpolate, attribute interpolate, to interpolate the position of the particles. So that's the destination geometry, that's the moving geometry, and that should give us a consistent moving points. Yes, and it's quite fast, as you can see. And the resulting grouping should be also faster because it's gonna work on less points. So if we go here, we are slightly inside, I guess. So it's gonna be 80 points. So we can give it a little rule like, oh, if you're more than 50 points, start shooting, which is fine. So what we can do now is we can create a blast just to get those points that are inside, and this should give us points only when we see our ship, which in this case I think may not be needed. But so what we want is that we want an attribute called fire, and we want this number. So like we can create an attribute called fire, attribute angle. It's going to determine if you're firing or not. So we can call it here at fire, I at fire equals 0. So no firing. So this will be our initial attribute, which should be actually here. Performance wise, actually, because this path is not time dependent, here is time dependent. So even though it's probably has zero effect on the CPU, it's a good practice. Just it's just an attribute creation, but ideally that's where it should be, because it's always going to be 0 in that level. So here we can then say get the. So if you look here, our geometry spreadsheet, I'm going to type it, then we're going to slightly optimize it. I at insight is equal to amount of points on myself, right? So here I have 1,000 points at okay, so here he's getting into the cone. So if I look here to my inside attribute, it's going to be like 794 points in, 64 points out, etc. So let's just go slightly here, and now I'm going to say if I at inside, integer inside is more than 10, then I at fire is now 1. So if there's more than 10 points, my value will turn to 1. Okay. So this I exported as an attribute that I can see. It's not a temporary attribute, but now I know that my condition is working. I just need to optimize it slightly better. So I only export fire. And this is done by declaring the attribute type, and then you just remove the @ sign, so it just works internally fine. So these are set condition, and let's drop in a null. And here we're gonna say inside. Inside. Okay, a little typo there. Okay, and now we can go up here. Here we can say target detection, fire trigger. Okay, so we can say here, this could be our target our eyesight or gun sight, I suppose. And here is our trigger detection. Trigger detection. Okay, fairly simple, but it works. Okie dokie. Now we're gonna move down to our particle system. At this point, we had our source where the gun nozzles are supposed to be. So we can come put a null here and say out gun animation or bullet source attribute wrangle to give initial burst direction of our particles by renaming equaling at velocity attribute to our normals, because remember our normals were looking at the direction our plane is flying anyway. And then I'm just gonna get rid of all this jazz that I don't need, so attribute delete, because remember that carries on in a particle simulation as a source, so everything except velocity, I guess, and group delete as well to remove everything I don't need. So I just have the source particles at the moment. I believe, yes, that's all I need. Now let's drop in a .NET and let's call this as what I call Gatling laser. Okay, plug it in. So I'm gonna go inside now, and we're gonna create a little bullet simulation using pop solver. So we're gonna drop in a pop solver, a pop object. That's gonna be our bullets. So I'm going to create now a pop source. Okay, so that's in fire. Okay, and then so what we're gonna do now is first bring in our source using points and using the first context geometry, because we plug the source into our first point here. So if I dive inside, we are starting from frame 100. Let's check that. Okay, that's good. So if I go plus, go to the first frame, look through the camera, let's see what's happening. It's always shooting now. Have we not linked the active yet? I guess not. Hit bullets. Have we not sourced it? Oh, because we are gonna link this in our simulation at some point. Okay, we can change the, because our bird is not now in the set to, because we haven't linked anywhere on when to fire, so it's just gonna continuously fire, although it's firing backwards because our inherent velocity is very low probably. So I'm just gonna go to inherent velocity and put something like 300. That depends on how fast is your ship moving, but now we are shooting forward. I guess it can be even more, because I think it starts going back a little bit, then forward. Where is it? Yeah, I think our bullets could be faster. Let's go 600. Okay, so it's kind of better now. But there's one thing we need to change is the constant activation. Remember, we have created here in insight. So at the point level, we get sometimes 1. But I think there's one thing though I may have skipped. We don't need that as a point attribute. We need that on a detail attribute. So I guess we can change that to let's call this one back initial val. We can just have this on a detail. So it's just gonna go here and run that on detail as well. So we just get update on the one attribute. So it's always gonna be 1 fire, fire, or no fire. So which means that we can use this attribute now to draw our constant activation value. So because we don't want an impulse, so we want a constant. So that goes by the way to fetch attributes again is by typing detail, point, or primitive, and then we need to show the path to our insight, then close the string, comma, get the attribute you want to fetch, comma, 0 is because maybe we have a vector, so that's how it's gonna be 1 or 0. So if I press play, no fire, at some stage start firing, was in sight, it's firing again. So now, one of the things that I wasn't very happy about it is in the original one, it was just, when it fires, it was firing very constant. So I think something that will be more interesting would have little bursts that we can add, which I haven't had before, but I guess we can make it pass through some really dense noise field, and that can just turn on ones and zeros much often, I guess. How can we do that? I suppose because we have these points here and we are passing them through. Where are my points? Here I have my points. Where are my points? Inside 998. I think it's stuck. I don't know, because I'm not showing the attributes. Okay, so I guess we can do something like this. Let's create a workshop and let's create a noise, turbulent noise. Let's plug into the position and then the CD. We already have, I think, a color here. Let's check this. I think we already have a attribute. Let's put an attribute delete to remove incoming color. Okay, so we have, actually this shouldn't, we wouldn't have to delete, I would assume. Yeah, that's fine. So maybe let's go something really, because our ship is flying through a lot of, it's flying really fast, so I think we need a really small frequency. So the color is, it's gonna always change, but we need something that basically changes every frame to 1 to 0, almost every 2 frames or something random. So we can use that value. So what can we do? Actually, we could do something more simple. We don't need that. Let's try to make this a bit more optimized. Attribute angle. So maybe let's create a random value based on position at p at rand trigger equals rand at p. So every frame, this is going to generate a random value, which we can create. Yeah, so we don't need another angle. Let's delete that. Let's go to set condition, and then let's create this guy here, which we don't need to export. And then I guess we can multiply our trigger. What happens if we multiply? Okay, let's leave that as a float. for now, so we can see the result. I'm gonna leave that as a float as well, and then we're gonna convert it to an integer. So here, because I'm going to see my fire like this, so in this frame it's gonna fire, in this frame it's not gonna fire. Where did it go? Never catches again. So one frame it will fire, 2 frames it will not fire, etc. So I guess we can do that times rand trigger, which means I don't want to export that, so it's a float. Okay, rand trigger, this is not correct. Rand trigger. Oh, okay, that's trigger. There's a little typo there, let's fix it. Okay, so now if we go here, oh, and then we need to convert that to an integer, and as long as it gives me 1 zeros and ones, but for it I think this won't work because it needs to go, okay, it needs to go over 1 to return 1. So what we can do is, if inside is bigger than 10, fire. Okay, so that maybe actually popnet may not need, well, we can just multiply that by 2, I guess. Yeah, that's kind of gonna work, I guess. Let me see. Should just do off. Okay, let's go inside the .NET to see. Look through our camera. Press play. Yeah, so we get some more randomness every now and then. 2, 3 firing, leaving a little gap. 2, 3 firing, leaving a little gap. But we're not firing enough. I think we're just not firing enough. Well, basically, if you want to fire more, just make that cone bigger. So let's call this eyesight, which means that if I make this 600, and then I can make this, I don't know, 40, which means that the ship is gonna be inside more often, which means that we're gonna fire more often. Okay, I guess now we can bring in our additional like the ground collision, I suppose. So we can do the pop replicate. Okay, so let's do that. At some point, I believe we said we're gonna create a VDB of our environment terrain, which we didn't, so it is now time. So let's turn on our environment geometry under our terrain, and let's now create our collision geometry, both from our ground and from our buildings. So what we can do, we can extrude volume here. Actually, let's move this to the left so we can prepare it here. Let's plug this in. In here we can say, yeah, so we just create a volume basically, and then we can convert this to VDB from particles, from polygon, sorry, something big, because we have a big environment. So that's going to define our accuracy of our impacts. Also, it's going to define how it's based on that, it's going to speed up or slow down our simulations. So I guess 4, I don't know, I go with odd numbers, even numbers, kind of makes more sense to me. Okay, so now let's drop in a null here, and we're going to call it out terrain collision. Okay, and we need to do the same thing for our scattered buildings, which we are going to use our This is broken. Let's create a new scene view, which we can use basically these models, because it's not going to be really we're not going to need so much accuracy, but like I said, I mean, we can use these guys as well, but we already have this, so we might as well just use these. It's going to be just faster. So let's create another VDB from polygons. Again, if you're making for a future movie, kill it. We need a bigger number before we run out of memory. Kill. No, I didn't save. Yeah, so that's a battle. Never plug in a VDB before actually maybe setting it to a proper value, or oh, come on. Please don't. It's gonna take too long. That's gonna be memory. My memory is climbing. I need to stop this. Oh, come on, side effects. Don't do this to me. Okay, I'm going to pause very quickly to resolve this problem, which is very funny. Okay, pausing. Yes, I managed to save the scene. Let's go 4 here and let's plug it back in. That should be reasonable now. Okay, maybe 3. Okay, even 2, I suppose. 3 is fine. Well, let's keep it the same resolution as the environment. Let's pull it a null here. Let's call it out city collision. Out city collision VDB. Okay, so now we can go back inside our ship guns dot network, create a static object. Let's call this terrain, create another static object, let's call it buildings. Okay, now we're gonna merge these. We can plug it in, we can change it to no change, and then we can drop in a static solver. Wrong input. By the way, for those who don't know, there's something funny about the static solver. I haven't checked if it's still in 17.5, but here it says the static solver DOP is a solver which does nothing to its object at each time step. So you don't actually need it to make it work. But it also says when using these solvers, there is no way to turn off solving other than using static solver. So we can use these guys to turn off certain solvers, pretty much. So let's drop in a merge node again. So this time it's going to go under here. It's going to be left effects, right input. So put the static solver on the left side. So we want to put a gravity as well, because we want our bullets to kind of lose speed and start falling down. We're going to put a drag force, which is pop drag. Drop it in here. It's just that something that really kind of gives them a drag, which is my default value in this scene is 0.2, but I am going to ignore mass, but I don't think I created mass anywhere, so that doesn't make any sense why I turned off the mass, which is not going to affect it. So we can leave it on. So the other thing now we want is to bring our terrain into where it should. So I'm just going to pin this, go into collisions, change the ray method to volume sample, division method to size. This we were using 4. This is actually inherited from the VDB here. The other thing I want is now to bring my sub object and then the proxy here, which was again up here. We just created, not here, sorry, here. So this is my proxy, and then this is my geometry. Okay, that's fine. Now we need to do the same thing for our buildings. which means this guy. Do the same thing. Volume sample by size. That's again 4. This time to our city visualization node, scatter and preview. VDB goes here. Geometry goes. I don't know if it works with. I'm just gonna unpack it to be safe. Just to get actual geometry, and I'm gonna create hard normals on this. Okay, so I'm gonna drop this guy in subpath, and that should do the trick. Now let's go back into our .NET. Look through our flight cam. If we dive in, we should have something is broken here. This guy. It's not. It's just a visualization. So if I press play, I should shoot, and then it should hit things. It's hard to tell. Let's disable. I think our drag is dragging too much. Let's disable it for now. Okay. Let's disable this because it's just a bullet. I don't think we need to drag it. Maybe just a little bit will be fine, but let's shoot now. It's shooting and it's bouncing off. Okay, so the collision is working. That's good. Now what I want is to change some physical settings. I don't want them to bounce as much. So we can go to the bounce settings, maybe go 3 here, and we can leave friction as it is, and then do the same thing for these guys, I guess. This was already, so both of them, 3. Then we need to, this is locked, my bad, sorry. I wasn't changing anything actually. So both of these could be 3 instead of 1, so physical here, maybe 0.4 whatsoever, increase the friction to 1. Friction is already here 1. Let's press play. It's gonna bounce less, I would assume. Ding ding. Okay, it's bouncing less, but we don't want to bounce so much. So now what we want to do is that when we have an impact, we want to duplicate create some spawn particles due to collision. So for that we can use pop replicate. And we are going to create a group. No, this is gonna create. I think was I creating it here? Source attributes. Not really. I think I created further down. Not boom group. It's here. Yes. So on the pop solver, under collision behavior, we're gonna turn on add hit attributes, and then we're gonna create a group called boom group, which is like it hits, so it boom. And then we can turn on this attribute section. I don't need a lot of attributes. I'm not gonna get the position and the number, and I'm not gonna get the path, hit prim, hit UV. I just want the normal velocity and time, and that should be good. If I need to, and I want to move these to move the hit, which if I do a mouse over, it explains what it does. Often if you want to trigger an effect of a particles collision, such as burning more particles, you want the particle at its location, not where it ended up at the end of the frame. So that was it does. So now what I'm gonna do is to pop replicate needs to work on this group, not on every group, otherwise it's gonna emit every frame. So if I take the update substeps, I don't think anything I have here apart from the substep settings. So it's 1, but I'm gonna go 4. That's what I did in my sim. Okay, let's go back. So now select the pop replicate, and then we're gonna rename this to hit bullets. Hit bullets. And let's play with the settings. I want to burn X amount of points, which we only have to play. On this life to be not so long, and I want the original particle to get out of the frame. And then if I go into the shape, I want to create some uniform scale and not so much of the original velocity, or more like a dispersion with a noise. So then in the noise settings, just how is the noise added to this source, and I guess that's what we can do. Then that should be enough. This should create new particles so we can see the color actually after it hits the ground. So now once they hit the ground, they should spawn more points, and those are the ones that we see there. Okay, so we want them to actually spread a bit more. So let's do that. I guess we can have more velocity. Maybe we should change the velocity stretch to 0.2 actually. So let's press again. So that's what's happening. Before it wasn't happening. Well, let's press play. We want some more random motion where it hits. Yeah, so kind of I think did work, but I guess we want something a lot more random. So I guess what we can do here is to add some more randomness, right? So what we want is that we want these particles to inherit the hit number as well. Might come handy. So I want some radial velocity, I guess that's what I need. So I want some randomly added motion to the originally hit particles. So we're gonna add this. So I punched in originally 555, 10, 10, 10, sorry, no, 2, 10. Again, these are just random numbers, you just have to play with them. At this stage, it should create stream hit bullets, boom group, stream in fire. Doesn't this create a new stream? Not sure. Stream in fire. Let's press play again. See what happens in this section. That's where the bullets hit first. Okay, so they're now a lot more dispersed. They're getting spread like bullets that ricochet from the land. So if you press play, okay, obviously that's a bit too much. I can see that already. So maybe 5. Yeah, it's better, but we need to add some kind of drag to this and some kind of randomization, I guess, which we can apply after. So I want more of these, so let's go, I don't know, 50,000 for the final simulation. So if you press play, maybe that's too much. Let's go pixels. Yeah, I guess that's too much, and that's way too organized still. So let's go, I don't know, let's go 5,000. What we can do next is to add a node called pop interact. That kind of gives a motion that particles stick together more, or they share velocities. So these are the values I used. You should give them a bit more random motion than very uniformly spread points. Okay, so these are like almost like dust that gets hit off the floor. Now what I'm gonna do is to create a little random mass to these guys, so we can also create outside in the simulation, sorry, we can create a pop-up. Let's drop in the pop-up here to generate, where is it? Here, but wouldn't that change the post-solve, pre-solve? I don't know, we can try. You can try to create a random mass based on ID, I guess. Based on ID, you can create a random value. So that would be random ID. So the input is integer, but we want a 3D output, which we can connect the position, which can generate, like now it's color, but what we want is mass. So bind export. We're just trying to randomize our motion, but we don't want something very so if we go, actually, if I really get close to here, because that's my position, then maybe make the points back to points so we can see the color. So I don't really want something very noisy, because here the values are changing quite often. So again, I'm gonna go and make something small noise. Okay, so now I have some noise, which means I can put my pop interact here. Now I say don't ignore the mass, which I'm gonna put it here, and then I can let's say create mass. Oops, create mass, and then I can put a drag as well. Drag force, sorry, drag force. No, drag force, no, pop drag. Yes. And again, I'm gonna go 0.02. Maybe not ignore. So let's press play, see what happens. This drag, it may be a bit too much, but no, it's not. So okay, we get a bit more random motion, but it's, I think now we are a bit too dragged. So let's go 4 times less. Let's see what happens. Just trying to get some good, better values. No, I think it's the pop interact. So I'm gonna go 0.1. Press play. Okay, it's a bit more broken up now, if I can. Okay, it's definitely more interesting. Now let's go and continue with our setup. So now what I want is that if my point is hit, and if it's not from the boom group, so the newly created, remove them. So for that, I'm going to use pop wrangle. That's the code I'm going to use now. I'm going to turn on the group. I'm going to say, if not from the boom group, run over the particles that are not a member of the boom group, which are the ones I'm creating from using the pop replicate. So here I'm going to say if at hit num is bigger than 0, remove point 0 from itself, point number. Okay, so that should get rid of some of the particles that are sticking on the floor. Which should be some of those that are actually on the floor. And here we are flying through some flying particulates. Let's actually let it go. And now it's actually also, I think, hitting some building there, which is cool. Let's see. It's from here. Actually, let's see it from here, because from there and there, which is pretty good. Cool. Boom, 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 boom. Okay, cool. That's cool. So it's gonna be there again. Some of the buildings. think that's one of the good things of having a tightly spaced building, so the bullet's gonna be hitting everywhere, which is cool. So it's gonna create a lot of sparkling renders from the building glasses, etc. And from these we are going to create building pyro simulations. Okay, so that's cool. So we need to bring in this geometry now. So what was our pop object called? Bullets. So copy this name and tell in object merge to only bring this information. So if you turn this on, it's like doc import, but we don't need so much stuff. So now I want to create an attribute delete, because as you know, if I scrub through, it comes with a lot of attributes, and those who may have purchased my previous tutorials knows that I'm really tidy about what to keep, what not to keep in terms of attributes. So I'm going to remove everything here, and we're going to create a little warp sop after this to define some colors to our particles, so they're like hot as they heat, etc. So dive inside the point warp. So I want to measure my length first using my velocity. So drop in a length swap, plug in V to length, which is measuring the speed. So I'm going to put a fit. In my previous sim, my top was 10, but we may have to play with that. And then I want to create another fit and plug in my age to my value. And in this fit I have source max 1.1. I think originally we have 2, but I'm here reversing my age by fitting the values front to back. Okay, and then I'm gonna create another random value here using the ID of my particles and converting it to a float, which is just to multiply my values with something. So let's create a ramp. I'm going to plug in the output of fit2 to ramp, and this is going to be a color ramp. We can just leave the name as it is, and that's going to drive our scale basically. Bind export, because I want to instance different objects to like a bullet shaped objects, long laser shaped objects to these particles. So I'm going to call this scale, but I wanted a float vector, sorry. We're going to play after based on some values, how to change those values. So again, for the color part of it, we have the random, we have the ramp, and we have our age. So now I'm going to create a ramp node again. We're going to call it ramp 2. This is the particle color. The fit1's input is going into the color. I guess we can move this up here. And then I want to put in a multiply node. So the first output is our original color. Then we want to multiply that with some random value. And then finally also multiply that with age. We'll plug it in here. And this is going to output as CD. Okay, so it's going to give us some colors, but now if you change the colors to something like more, I guess this one we can call, actually let's give those ramps some name, bullet scale. Okay, and then this color is bullet color, because that's going to drive the intensity of the emission. Okay, and now if you go outside, come on, and let's give this some fiery colors, which we can. It's mostly orange and yellows. Okay, so this is where we need to play with the fit. Because what I want is, while they're flying, I want them to be super hot, but not white. maybe we should first not use these to get the right color, and then use the where is our bullet color fit is here. Okay, so our particles are a lot faster, I guess, which we can see the result, so we can plug in the length straight to CD, and it's going to tell us some crazy numbers, which is 600, which is our output of color, which means you can put a 600 here if you want to normalize our values. And this is the one. No, this is the one. Okay, so that's the part that I want it to be a bit more interesting. Let's check it out what happens on the building. Okay, it's not so bad already. Now let's try to give it a bit more random, so it's not always yellow on orange, by plugging back in our noise. Okay, so it's just going to change the values a bit more random. And then what did we plug in? The age as well, right? So okay, they're just like little explosions as soon as they hit. This way, when they fly, even if they don't hit, so there's going to be like they're based on how old they are, if they had an impact, etc., which is going to look a lot more interesting. So if I go visualize everything, it's pretty cool. Okay, it looks pretty alive. So we can bring these guys down, and we're gonna put I'm gonna copy paste this one file cache. This is just gonna be a geo OS. It's gonna point to your folder. This is up to you. That's fine. And we are going to 600, not 1200. And we're gonna cache it. And I'm gonna stop this video, and then we're gonna move to the pyro explosions from these caches. So we're gonna cache this. In the next video we'll make pyro explosions. Thank you for watching.